Alright, in this video, we will continue to discuss solving linear equations with one variable, but here we will talk about what we call special cases. Alright, some special cases, well, two of the problems here, number 1 and 3, will be relatively obvious. So let's look at number 1. It says x plus 2 equal to x plus 2. Alright, you may say, yeah, sure, they're same, so aren't they supposed to equal? Well, what you are asked to find is find number or numbers that will satisfy that statement. What statement? A number added to equals to the same number added to. Well, as a matter of fact, all numbers will satisfy this. Let's say x equal to 0. 0 plus 2 is 2, and 0 plus 2 is 2 on the other side, so and 2 is equal to 2, so isn't that obvious? Well, it is obvious, but I'm discussing this because there are some non-obvious or less obvious situations, special cases, so that I will discuss how you can identify these special cases and write down the proper way to write the answer. All right, we're going to try to do the same thing where we usually will, when you have x on both sides of the equations, we will try to bring them to one side. So that's what happens. So we have this x subtract x is equal to negative 2 plus 2. Okay, and what happens? What's x minus x? What's 0 is equal to negative 2 plus 2 is also 0. And yes, 0 is equal to 0. And this is what we call consistent, or sometimes true statement. When this happens, after the variable got removed and you end up with a consistent or true statement, then the solution to this special case equation is set of all real numbers. Any number will satisfy this. So there are several ways you can write the answer. You can just say the answer is all real numbers, or you can also write this way: x set of all numbers that belong to a set of real numbers. Or better yet, you can say set of all x such that x is this special looking R. Doesn't look very good. Let me rewrite that. This is called like double capital R. That stands for all real numbers. Okay, and there's even another way. So what we call interval notation, starting from negative infinity to positive infinity. All right, so any of these three is acceptable, or I think sometimes I just saw some people just writing this. Okay, so any of these four is acceptable way to write the solution. All right, okay, let's go to number 2. Number 2 doesn't look anything like number 1, but it turned out to have a same answer, which is set of all real numbers. So let's go and do our usual routine. So distribute the parentheses, remove the parentheses by distributing. So 4x plus 20 is equal to 4x plus 6 plus 14. And hope you realize what we end up with is, again, identical left-hand side and right-hand side. And if we try to do the usual routine of subtracting negative 4 on both sides, subtracting 20 on both sides, what will end up is same situation as previous problem, that 0 is equal to 0. All right, so again, the answer is same as the problem number 1, which is set of all real numbers. Okay, so I can just write this as my solution. All right, number 3. Number 3 is total opposite. It reads x plus 2 equal to x plus 3. Can you find a number such that when you add 2 to it, that'll equal the same number added 3? No, this is impossible. There's no way this can happen. And let's see what happens if we try to do our routine. X minus x, because I moved over the right hand side x to the left hand side, and negative 2 because 2 moved over from left to right. And what we end up with is 0 is equal to 1. Well, we know 0 cannot equal to 1. 0 is not equal to 1. They're not same. So this statement is totally false. And this is the opposite of what we have seen in problems 1 and 2. This is what we call inconsistent or false statement. It is false that 0 is equal to 1. Okay, when this happens, the answer is no solution. No real numbers will satisfy this. Okay, and there are several ways of writing. You can just say no solution, or sometimes people say the solution set is empty. Okay, and one way of writing is this. I do suggest that you don't use that second symbol, because that can be confused as 0. And it is very wrong to say that x equal to 0 is a solution to this problem. Okay, or there are several ways you can say empty set, or sometimes you can say null. My use looks, come on, null set. Okay, any one of those 4 is acceptable. All right. Okay, number 4, last one. Doesn't look anything like a simple problem like number 3, but let's see what happens. Distribute the 3. 27c plus 3 minus 18c is equal to 9c plus 6 minus 8. All right, I just did a straight distribution on both sides, and let's see what happens. 27c minus 18c is 9c plus 3 is equal to 9c minus 2. Okay, and now hope you will see that it's similar to number 3. If we subtract 9c on both sides, what we'll end up with is 9c minus 9c is equal to negative 3 minus 2, or 0 is equal to negative 5. Again, false statement. 0 is not equal to negative 5. So our answer is same as problem number 3. This is an inconsistent or false statement. There's no solution, empty set, null set, whichever you choose to